a particle starts from a fixed point O, let me jot down some information over here. So we know when you start from a fixed point, the time starts ticking. Therefore, we have time equals to 0 at this point O. And move in a straight line towards point A, its velocity v meter per second, t seconds after leaving O is given by v equals to 6 minus 4e power negative 2t. The particle reaches A when t equals to ln 2. Part 1, find the velocity of the particle at O. Now that we have info to do part 1, because we know that time equals to 0 at O, another information is whereby they have given you here t second after leaving O. That's the second indication that time starts at point O. So now we have part 1. To find the velocity, we substitute 0 into the t position. So we have e power negative 2 times 0. This will lead to the answer of 2 meters per second. Now let's take a look at part 2. Find the acceleration of the particle. Now be careful, it's not O anymore, but it's at another point A. And we know the time at point A is ln 2, but we do not have the expression for acceleration. So step 1 here, we're going to find what is acceleration expression. Based on velocity, we can find acceleration by doing differentiation. So I'm going to write down, we're doing dv dt. Let's differentiate that expression. Differentiation of 6 is going to be 0. Let's focus on expression of exponential part. I'm going to copy back negative 4e power negative 2t. And differentiating power here, I'll have negative 2. Let's simplify. Negative 2 times negative 4 is going to be 8. So now I want to find at A. I'm going to substitute the time value at A, which is ln 2. So I'll get my answer here as 2 meters per second square for acceleration. Now I'm going to erase a bit here to discuss part 3. Let's take a look at part 3 of this question. Explain why the particle never comes to rest. Let me underline this word here, never comes to rest. We all know at rest, v must be equals to 0. So never at rest, meaning v can't take the value of 0. But do take note that you need another information where t must be more than or equals to 0 here. Let me show you two methods here. Method number 1, we're going to just equate velocity to 0. So I have 6 minus 4e negative 2t equal to 0. We're going to solve for the time for this equation here. So I'm going to move 4e power negative 2t to the right, then divide by 4. Next step, take ln both sides. And now I'm going to divide by negative 2. So I write it this way. And I'm going to click my calculator here. I will be getting negative 0.203. So I'm going to explain this is rejected because time must be more than or equals to 0. So I'm going to explain, therefore, never at rest, v can't take the value of 0 for time more than or equals to 0. So this is method number 1 here. Now let's take a look at what other ways we can explain. So this method number 2 here, I'm going to write down velocity as 6 minus 4e power negative 2t. Now remember part 1, we know that velocity is 2 when we leave O. So what I have here is that I'm going to sketch a graph for velocity versus time. And I know I'm starting at 2. So this standalone number here is where your asymptote is. So I'm going to plot here 6 with a dotted line. Now if you do not know how to sketch an exponential graph, let's just test a value of time. Since this 2 here is when time 0, let's just test what happened when time is 1. So I'm going to click my calculator. I'll be getting a value of 5.46, which is very close to 6. So the graph will be approaching 6 this way for your exponential graph. So I'm going to explain for time more than or equals to 0. velocity value will fall between 2. So I can take the value of 2, so I'm going to write more than or equals to, and this is velocity value. And velocity is always lower than 6, so I'm going to write less than 6 here, okay? And from here, we clearly can see that because velocity can't take the value of 0 for time more than or equals to 0, therefore, never at rest. Okay, so you can see it in the sketching graph perspective instead of method number 1 here. Next, let's look at part 4 of this question. Find the distance between O and A. Remember part 3, we have proven the particle never come to rest. So to find the distance is the same as doing displacement. So I'm going to do direct integration. So for this part 4 here, I'm going to find S by integrating from 0, this is from O, to A. A is going to be taking the time of ln 2. And I'm going to write velocity, which is 6 minus 4e power negative 2t. And remember this expression in t, I'm going to write dt here. Let's integrate this expression. Integrating 6 with respect to time is going to be 6t. For exponential part, I'm going to copy and remember to divide by coefficient of t, which is negative 2. So I'm going to change this to a square bracket and write this at the back here. Next time, I'm going to simplify a bit here. I'm going to do negative 4 divided by negative 2. I have a positive 2 here. And the next time, I'm going to substitute this ln 2 first. So I'm going to put minus and now substitute the value of 0 at the t position. So I'm going to just do 6 times 0, that's a 0. And be careful over here. So because you're putting e to the power 0, this one here has some value. So I'm just going to leave it this way and type my calculator. So I should be getting the final answer as 2.66. So since it's a positive, this is also answer for distance.